Today's lesson is on compound events and covers pages 190 and 191. The first few questions deal with a situation with Jade and Laura who have a box of marbles. So there's some red marbles, green marbles, and blue marbles. Laura draws a marble from the box and she leaves the marble outside of the box and draws a second marble. There are 5 marbles in the box for the second draw. So first we need to list all of the outcomes of Laura's second draw if on the first draw she draws a green marble. So what happens here is she's pulled a green marble, so you're listing all the ones that are left. So there's one red, another green, 2 blue, and another green. So that's where they've gotten this list from. So for 2, a blue marble, take one of the blue marbles out of the equation and then write all the ones that are left. We'll do the same thing with a red marble. Take out the red marble, write what's left. For B, does the list of possible outcomes of the second draw change with the result of the first? So you might notice that are these lists the same or different? So if they're the same, then it doesn't change. If they're different, then it does change. So that's question 1. For question 2, Jade draws a marble from the box and she places the marble back and draws a marble again. So instead of taking a green marble and leaving it on the side, she takes it out, sees it's green, writes down that it's green, and then puts it back. So what are all the outcomes for her second draw? Well, if she takes the green marble out and puts it back, will she have all these marbles? Yeah, so you'd write down all the marbles. If she takes out a blue one, she puts it back, what are the marbles inside the box? Write it on the list, do the same thing for red. Then you're going to look and see, does the list of possible outcomes for the second draw change depending on whether she pulled a green, a blue, or a red marble first? So if the lists are all the same, they don't change. If they're different, they do change. 2 events are independent if the outcome of one event does not depend on the result of the other event. So we're going to be looking at dependent and independent events. So for question 3, they ask whose pair of draws is independent, Jade's or Laura's? So for Laura's, right, and Jade's, you're looking at which one doesn't change between what the possibilities are for the second draw. If it doesn't change, then it is independent. Okay, so that will be the factor. Which one doesn't change? The next few questions will still be relating to this question of whether an event is dependent or independent of a previous event. So the question for number 4 is, are these pairs of events independent? So does the first one change the option of a second one? Right, yes or no? So draw a marble from a box and spin a spinner. Does what marble you draw change your options for spinning the spinner? No. So this is an independent event, right? They do not affect each other. Spinning 2 spinners. Does spinning the first spinner change how you spin a second spinner? If it doesn't, it is independent. Pulling 2 coins, one after the other, without replacing from a bag. So if we look at this one, if you pull a coin and then you have to pull a second one, but you don't put the first one back, does that affect the coins that you could choose? Yes, because the first one will no longer be an option. So this would not be an independent event. So if that makes sense, right? If the 2 events don't impact each other, then they're independent. But if it affects what the options are, they are not independent. Part 5, question 5, asks you to choose a pair of independent events from question 4 and explain why they're independent. Okay, so we've already mentioned 2 of them. You explain why the first event does not affect your options of the second event. Question 6, Bob and Nick each have a box of 3 marbles, 2 red and 1 green. Bob draws a marble, lists the color, places the marble back in the box, and draws a second marble. Nick draws a marble, lists the color, and leaves the marble outside the box. Then he draws a second marble. So we have 2 different situations here. So question A will ask you to draw a tree diagram to show the possible outcomes of each person's draw. So at the beginning, for each person's question, you can start, I sometimes put who the person is, right? So if I have Bob, and Bob is drawing a marble, and there's 2 red and 1 green, they will both start the same way, right? They'll both have the same first options. The difference will be who has options the second time, right? Bob drops a marble, lists the color, places the marble back, and draws a second marble. So he still has 3 marbles when he chooses his last one, whereas Nick, he draws the marble, lists the color, leaves the marble outside. So he actually only has 2 left to choose from. I have not filled in the bottom row for you to list those choices. I'll let you do that on your own. But look at, if he pulled a red one here, he has a red and a green left. So that's what those letters would be. If he has a red one here, what would he have left? Green one, what would he have left? B asks you who has more possible outcomes, Bob or Nick. So however many branches we have in our final row is the number of possible outcomes. So who has more? And C, whose way of drawing 2 marbles is independent, Bob or Nick? So which one doesn't impact your next row? Question 7, part A asks you to write a set of ordered pairs to show all the combinations you could spin on the 2 spinners. So if you notice, they filled in part of them for you. So they've said, well, you could spin a 1 and an A. You could spin something else in an A, something else in an A. So they've given you 3 options with A's so that each of the 3 numbers can match up with them. Then we need each of the 3 numbers to match up with the letter B. So you'll fill those in here. B asks you how many outcomes are there, so count the total number of outcomes. And C, how many ways can you spin a 1 on the first spinner and an A on the second? Okay, so how many of these have a 1 and an A? This one does. When you finish filling it in, see if any of the other ones do. How many ways can you spin an odd number on the first and a B on the second? So you'll look to see, where is there an odd number and a B? How many of the outcomes fit that characteristic? D asks you to state the probability of spinning each situation. So remember that the probability, your top number, is going to basically be your answer to this question out of the total outcomes, which will be your answer to this question. So it's almost like this box over this box, and then same thing, this box over this box. We'll write them as fractions. Then we'll start looking at experimental probability. So experimental probability of an event happening is when you actually test out how many times it happens. So you'd figure out the number of times A has happened over the number of times the experiment was performed. So part A for this question asks you to write a set of ordered pairs showing all the combinations you could spin on these 2 spinners. So when you spin a 1, you could spin an A, a B, or a C. When you spin a 2, you could spin an A, B, C, 3, A, B, C. So you need to have that whole list written out for A. B asks you to state the probability of spinning a 1 on the first spinner and an A on the second. So how many options have 1A? That will go on the top. The bottom will be your total outcomes. An odd on the first and a B on the second. So how many of those outcomes fill that category out of how many outcomes are there altogether? C asks you to spin the spinner 30 times. Now, here's the easiest way to spin a spinner. You will need a paper clip and your pencil or a pen. And so the easiest way to do this is to lay the paper clip on your page, kind of like this, and then stick your pen on the inside of it, right at the center. So it's kind of the anchor, And then you would come and flick the paper clip with one of your other fingers so that it spins around and around and around, and when it stops, then you can say that's what you span. Then you can move your paper clip and your pencil over here, pencil firmly on the dot, and then flick your paper clip so that it spins around and around and around, and see where it lands. So you would do that 30 times. So say you span it, it was landed on the 2C. So that would be your first one. You would keep a record, 2C. Now you'd be looking how many times did you get each of the results in B. Okay, I believe when they're asking for each of the results, they might be looking for these two outcomes. And they're asking what is your experimental probability for each event. So your experimental wouldn't be the theoretical. There's like one way of getting 1A out of 9 outcomes. It would be I span it 30 times, and if it landed on it 6 out of 30 times, you would put 6 out of 30. That would be your experimental probability. Question 9 talks about Jason, who has a $5 bill and a $10 bill in his right pocket, and a $5 bill and a $10 bill in his left pocket. So he pulls one bill out of each pocket. Question A asks you to list the combinations of bills he could pull from his pocket. So sometimes I'll make like a tree diagram to start it and go, okay, first he's going to pull out of his left pocket, so he could pull a $5 bill or a $10 bill, and then from his other pocket, his right pocket, he's also pulling a 5 or a 10. So you could then take a tree diagram like this and follow through all the combinations to list all of those outcomes. So that would be question A. Question B asks what's the probability that he will pull a pair of bills with a total value of $10. So think of what a pair of bills would have to be that equals $10. So will 2 10s work, or is it only 2 5s? So that would be how many ways can you get that out of how many options altogether? C, performs Jason's experiment 20 times. So if you have 2 5s and 2 10s, great. If you don't, take a piece of paper, rip it into 4, write $5 on 2 of them, $10 on 2 of them. Make sure you're following the criteria. So you have a 5 and a 10 in one pocket, a 5 and a 10 in the other, and pull them out of your pockets so that you can see how many times do you pull a pair of bills with a total value of 10. So you would need to keep a list, keep track of 20 times, but also keep track of how many times you got $10. D asks you what your experimental probability of pulling such a pair is, and if it's different from your answer to B. So B, we were calculating the theoretical probability. So these are the odds of it happening. D, we're calculating the experimental probability. I did this 20 times. Here's how many times I got it. So you might have the same answer, you might have a different answer. Just explain what that difference is. Also remember, your probability for theoretical might be out of 4. Your experimental would be out of 20. So you could, if it worked, that you could simplify it. That might be fine, but if not, you could always multiply your theoretical probability by 5 to figure out what your theoretical probability would be in the same ratio as your experimental. Question 10 tells you that cereal boxes come with a picture of either a cat or a dog inside, and there are the same number of boxes with each picture. You win a prize if you collect one of each picture. So, draw a tree diagram to find the probability that you will win a prize if you buy 2 boxes, right? So, if we start, I'll do one for you. We've got 2 boxes. So, the first box, you can either get a cat or a dog. The second box, you can either get a cat or a dog. So you need one of each picture. So this, when you get 2 cats, would not get you a picture, right? But this one would, a cat and a dog, right? You could get a dog and a cat, but not a dog and a dog. So there's 2 ways to get it out of 4 options. So you would have 2/4 or 1/2 probability of getting a prize. Then when you go to 3 rows, the difference is that you will have 3 layers coming down. So then you'll have to put in the correct dogs and cats and the probability. Now, question B asked, does the probability of winning the prize increase with the number of boxes you buy? And did you expect this? So do you have better chances? Is it more than 1 out of 2 times likely that you will get it if you buy 3 boxes or if you buy 4 boxes, right? So just calculating how many ways can it come out of how many total options are there. So this one, when we have 3, you'd have 1, 2, 3, 4, 5, 6, 7, 8 options, and you'd see how many would go. You can simplify them to see how close to 1/2 you get. That's all the questions for this assignment. There'll be some Google Forms attached for you to fill out, and feel free to send me a comment if you need to set up a meeting.